So welcome to session 5 of our Pre-Leaving Cert Algebra revision course. This video is going to take a look at solving simultaneous linear equations in two variables. As we move into Leaving Cert, we'll see other types of simultaneous equations, including simultaneous linear equations in three variables, and we'll see simultaneous equations where one of the equations is linear and the other equation is non-linear. Remember that linear equations are ones where the highest power in the equation is 1. And we'll look at that more as we go through the examples. The plan is to look at 10 key examples, so each one slightly different than the previous, so that we'll get a lot of variety in the types of questions we can be asked. Each one probably slightly more difficult than the previous as well, so that the level of difficulty increases as we go on. We'll also then look at 10 trickier examples, and as usual I'd advise students who are comfortable already with simultaneous equations to probably jump to that section and try those questions. They're taken or adapted from Leaving Cert higher level material and more difficult, say, junior cert higher level questions or Leaving Cert ordinary level questions that were of a higher standard. So let's start our revision of simultaneous equations by looking at our first example. So in example 1 we have two equations. We have x plus y equals 11, and we're going to label this equation 1, and we have x minus y equals minus 5, and we're going to label this equation 2. It's really important to label the equations at the start of the question, as oftentimes we're going to have to manipulate these equations to get them in a particular form. And so if we label them at the start, we'll be able to track which equation is which throughout the question, and it'll also make it handier if we have to go and check our solution. If we've made a mistake and we have to go back and see maybe where that mistake was. If we've labeled each equation all the way down through the question, we'll be able to follow it back to the start and correct our solutions more easily. Why are they called linear equations? Well, if we write down equation 1 first of all and just explore that particular equation. So equation 1 says that x plus y equals 11. The highest power in this question is 1. We have an x to the power of 1 and we have a y to the power of 1. We have no x squareds or y squareds, we have no x cubes or any powers really that are higher than 1. And so an equation of power 1 is called a linear equation. We have two variables, so that's why we need two equations to solve for it. So the variables are x and y, and we're trying to find those values. The last line of our equation should be x equals a particular number and y equals a particular number. We'll see that we need two equations because x plus y equals 11 actually has infinite solutions. If we test a few solutions, if x was 8 and y was 3, well, that's a valid solution for equation 1. If I tried 7 and 4 though, that's equally a valid solution, and there's infinite valid solutions to it. I can have negative numbers. I could have 13 minus 2 equals 11, so x would be 13 and y would be minus 2, and that's a solution. So to have two equations, we know that the answers for x and y have to satisfy both. So if I write down the second equation, so equation 2, x minus y equals minus 5. Let's see if 8 and 3 satisfies equation 2, and if it does, well then that is the solution to this simultaneous equation. So if I put in 8 for x and minus 3 for y, and see, is that minus 5? It's not. 8 minus 3 is plus 5, and plus 5 is not minus 5. And so x is not equal to 8 and y is not equal to 3, even though it did satisfy equation 1. We're looking for solutions that satisfy both equations, and there will only be one value for x and one value for y that satisfy both of these equations. So let's look at the method we're going to use to solve these equations. So the first thing we're going to do is we're going to make sure that each of these two equations is in the correct format, and the format we'd like to use is that the equations are of the form ax plus by equals c. In other words, the x term comes first, then we have the y term, then we have the equal sign, and then we have whatever number is in the question on the other side. So at the very start of a question, we look at the two equations and we spend some time getting one or both of these equations in this format. We can see that both of these equations are already in this format. Equation 1 says x plus y equals 11. So the x term, then the y term, and then the number term on the other side of the equals. And equation 2 likewise has x first, then it has the y, then it has the equals, and then it has the number. So these equations are ready to go. So the process we're going to use to try and solve these equations is called elimination. And with elimination, what we try and do is we try and eliminate or get rid of one of the letters, the variables in the question. And so you're going to see as I go through this first example, I'm going to eliminate the letter y. I'm going to solve for the letter x, and then when I have a value for x, I'll be able to go back and find out what y was. So to perform this elimination, we're going to write one of the equations directly above the other one. So we have equation 1, x plus y equals 11, and then that's going to be directly above equation 2, which is that x minus y equals minus 5. So in this particular example, I can see that by adding these two lines together, I'll eliminate the y's. Now in other questions, we're going to have to do some work to get the equations in the correct format or to get the letters to cancel once we add the two lines. But in this version, I've started with quite an easy version because I wanted the y's to cancel when I added the two lines. So if I add line 1 to line 2, I get x plus x is equal to 2x. I get plus y minus y, and plus y minus y is going to be 0. So there's nothing there in the y column. And then I have 11 minus 5, which is equal to 6. So as we go forward and we do these equations, we obviously don't have to write down plus 0y or plus 0. But we're just having a look in the first equation of an example how when we added all of the columns together, the x's added to 2x, the y's added to 0, and the numbers added to 6. So we have a simple linear equation now, 2x equals 6, and if I divide both sides by 2, I get that x is equal to 3. So we can see by eliminating the y variable from the equations, we're able to solve for the x variable. Now that we have the value of the x variable, what we're going to do is we're going to sub this back into either equation. So I'm going to sub in x equals 3. So I'm just going to sub it into the first equation. So it doesn't matter which one we sub it into, we'll get the same answer regardless. But if I sub it into equation 1, where I knew that x plus y equals 11, well, this is common sense. Most people will probably do this in their head. If x is equal to 3, 3 plus what number equals 11? Well, clearly 3 plus 8 is equal to 11. So I know that y is going to be 8, but we do the substitution anyway because some of the equations will be more difficult and we won't be able to do them in our head. So subbing in x equals to 3, I have 3 plus y equals 11. I'm going to subtract the 3 from both sides to get rid of the 3 on the left. So that means that y is equal to 11 minus 3, and 11 minus 3 then is 8. And so the solutions to this simultaneous equation are that x is equal to 3 and that y is equal to 8. And it's no harm just to put that solution together at the end, because quite often we'll have done so much work on the page that it can be tricky for the person correcting your paper or looking at your work to go and see where the two answers are. So by placing them together at the end, it just makes it easier for the person having a look at the work. So with the following examples, what we're going to do is we're going to change each question slightly just to advance the learning and teach something slightly different each time. So in the second example, we have 2x plus y equals 8. I'm going to label that equation 1. And we have that 3x plus y equals 11, and I'm going to label that equation 2. We're going to check first, are they in the correct format? So the format, remember, is ax plus by equals c. And they both are, so both of them start with the x term, then they have the y term, then they have the equals, and then the number on the other side. So they're ready to go. The problem with this equation is that if I write them directly above each other, and we'll do that to start, so 2x plus y, 2x plus y equals 8, and then that's directly above the second equation, which is that 3x plus y equals 11. I can see that if I go to add both of these lines, I'm not going to cancel or eliminate any of the variables. 2x and 3x is 5x, and if I add the y's, plus y and plus y is 2y. So we can see that one of the letters would not be eliminated if I don't manipulate or change one of the equations. We're always trying to get the letters to have opposite signs before they cancel. So I can see that these two y's aren't far off cancelling or eliminating from the other, but one of them would need to be a minus. And so what we're going to do is we're going to multiply one of the lines by minus 1. So I'm going to write down equation 1 again. So I'm not going to change equation 1. It's going to still be 2x plus y equals 8. And so that the y's will eliminate, I'm going to multiply equation 2 by minus 1. And so the way that I like to do these questions is I like to write down the label and then beside it, what's the manipulation of the line? What are you doing to the line to change it? So I'm multiplying equation 2 by minus 1. So if I multiply all the terms in equation 2 by minus 1, I get 3x times minus 1 is minus 3x. Plus y times minus 1 is minus y. And then 11 times minus 1 is minus 11. And so I had these two equations where the elimination wasn't going to occur if I added the two lines. And by multiplying one of them by minus 1, I know that if I add the two lines now, the y's will eliminate or cancel. So let's add the two lines together. 2x minus 3x is minus 1x. Plus y minus y is our elimination or our cancelling. And 8 minus 11 is minus 3. So I have minus x equals minus 3. I'm going to divide both sides by minus 1 and I get x equals 3. And so similar to the last equation, I've solved for x first. And now that I have x, I'm going to sub that value for x into either of the other two equations. Now, when you're choosing which equation to sub it back into, we generally pick the one where the signs are pluses. That's always easier than working with minuses. And then maybe the one where the numbers are a little lower and the mental arithmetic might be a little easier. So I'm going to sub x equals 3 into equation 1. But remember that if you subbed it into equation 2, you'll still get the same value for y. So we're going to write down equation 1 again, 2x plus y equals 8. I'm going to sub in x equals 3 because I now know that x has a value of 3. So plus y equals 8. 2 times 3 is 6, so 6 plus y equals 8. I'm going to subtract the 6 from both sides and I get y equals 8 minus 6. And y finally equals 8 minus 6 is 2. And again, I'm just going to put the two solutions together over here on the left hand side. X equals 3 and y equals 2, just to make it easier for both myself and for whoever might be looking at my script or my paper to check what the solution is without having to look too much on the page. Now remember that x equals 3 and y equals 2, they're the only solutions to this simultaneous equations. X and y cannot take any other values so that they'll satisfy both equation 1 and 2. We're not asked to verify in this question, but just to verify it quickly, if we verify equation 1, we have 2x plus y equals 8, so 2 by x, which is 2 by 3, plus y, which is 2, equals 8. And I can see that, yep, 2 by 3 is 6, and 2 does equal 8. So it satisfies equation 1. And just to really quickly check with equation 2 says that 3 by x, so 3 by 3, plus y, and y is 2, equals 11. 3 by 3 is 9, and 9 and 2 is 11. So we don't have to do that verification every time, but if you're unsure of your answer and if you just want to check that you're correct, sub those two values for x and y into both equations, and if you get valid statements, well then you know that they are the two solutions, and they're the only two solutions to this simultaneous equation. So let's have a look at what might be different about example 3. So I'm going to start the question by writing down both equations and labeling them. So equation 1 is the equation 9x plus 2y equals 17. And equation 2 is the equation 4x plus y equals 7. Now, I can see that by adding these two lines together, I'm not going to get either the x's or the y's to cancel or eliminate. So what I'm going to have to do is I'm going to have to multiply either equation 1 or equation 2 by some number so that there will be elimination. Now, what could I multiply equation 2 by so that either the x's or the y's will eliminate? Well, I can see that if I multiplied equation 2 by minus 2, well then the top line would still have a plus 2y, but the bottom line would now have a minus 2y, and those would eliminate. It looks to me like it might be a little difficult to try and eliminate the x's. Equation 1 is going to stay exactly the same. We want there to be a 2y in equation 1. So we have 9x plus the 2y equals 17. So we haven't altered it at all. Equation 2 then, every term on the left and on the right has to be multiplied by minus 2. So 4x times minus 2 is minus 8x. Plus y times minus 2 is minus 2y. And then 7 times minus 2 is minus 14. And again, I draw my line underneath, and I'm going to try and add the lines to eliminate the y's. So 9x minus 8x, first of all, is plus 1x. 2y minus 2y, they eliminate or cancel out, and that gives us 0. And then the numbers, we have 17 minus 14 equals 3. And so once again, we have x equals 3. Once again, we've solved for the x value first. Now we'll see going forward, we don't always have to solve for the x value first. It's just happened that it's been easier to eliminate the y's in the first 3 examples. Once we have our x value, x equals 3, we sub it into either equation. I'm going to sub it this time into equation 2 because it looks like the numbers are a little smaller and easier to work with in that example. So equation 2 is 4x plus y equals 7. I'm going to sub in x equals 3, so I have 4 by 3 plus y equals 7. 4 times 3 is 12 plus y equals 7. I'm going to subtract 12 from both sides to leave me with y on the left equals 7 minus 12 on the right. And then finally, y is equal to 7 minus 12 is minus 5. So the final solution to this simultaneous equation is that x is equal to 3, and we have y is equal to minus 5. So example 4 is an example of a similar difficulty to the last one, or similar style, but this time we're just going to eliminate the x's to show that it doesn't have to be the y's that get eliminated first in a question. So equation 1 is 3x plus 5y equals 13, and we have equation 2 we're going to write directly below it, which is x plus 2y equals 5. Now again, both equations are in the correct order, something x plus something y equals some number on the other side, but this time it's not going to be easy to eliminate the y's unless we were to multiply the bottom line by a decimal number or a fraction, and that's not something we're interested in doing. So in this example, I can see that if I multiplied the bottom line by minus 3, well then on the top line I would have a plus 3x, and on the bottom line I would have a minus 3x. And so it seems in this case that it's going to be easier to eliminate the x's than eliminate the y's. So I'm going to write down equation 1 again. I'm going to keep equation 1 exactly as it is. So 3x plus 5y equals 13. And then equation 2, I'm going to multiply the left-hand side and the right-hand side by minus 3. So multiplying x by minus 3, I get minus 3x. Multiplying plus 2y by minus 3, I get minus 6y. And then multiplying 5 by minus 3, I get minus 15, and I'm going to draw my line underneath to add the two lines together. So first of all, 3x minus 3x means that the x's are eliminated. They give us 0. Then we have 5y minus 6y gives me minus y, and 13 minus 15 is equal to minus 2. Now if minus y is equal to minus 2, if we divide both sides by minus 1, I get y is equal to plus 2. And so this is the first example where I've solved for the y variable first, and now I'm going to sub this into either equation to solve for the x variable. So subbing in y equals 2 into either equation, so having a quick look at the equations, I can see that it's probably easier to sub it into equation 2, which is that x plus 2y equals 5. So I have x plus 2 times y, which is 2 times 2 equals 5. X plus 2 times 2 is 4, so x plus 4 equals 5. I'm going to subtract 4 from both sides to get x is equal to 5 minus 4, and finally x is equal to 1. So in example 4, we have a final solution of x equal 1 and y equal to 2. Now, example 5 is the first example where it won't just be enough to multiply one of the lines. We may need to multiply both of the lines to eliminate one of the letters. So let's write down the two equations once again. We can see that they're in the correct format. So equation 1 is 2x minus 3y equals 9. So we have the x, then the y, then equals the number. And then equation 2 likewise is in the correct format. We have 5x. Then we have the 2y, and then equals, and then the number 13. So taking the x's first of all, I can see that 2 doesn't divide evenly into 5, and so there's no whole number I can multiply the top line by, so that the x's will eliminate. Similarly, I can see that 2 doesn't divide evenly into 3, and so there's no whole number I can multiply the bottom line by to get the y's to eliminate. So what I'm going to have to do in this example is I'm going to have to multiply both the top line and the bottom line by some number to get the x's or the y's to eliminate. So I'm going to decide to try and eliminate the y's. There's no problem if you decide to go and try and eliminate the x's, so there's no particularly right order in this. I decided on the y's because they already have different signs, and I decided that when I was eliminating them, if they had different signs, it just might be slightly easier for the multiplication of both lines. I'm going to turn both the y's into the lowest number that 3 and 2 both go into, and 3 and 2 both go into the number 6. So I'm going to multiply the top line by 2 to turn the minus 3y into a minus 6y, and I'm going to multiply the bottom line by 3 to turn the plus 2y into a plus 6y, and then the 6y will cancel with the minus 6y and we'll eliminate the y's. We could eliminate the x's. We'd multiply the top line by 5 and the bottom line by minus 2, turning the top line into 10x and the bottom line into minus 10x. So it doesn't really matter what you decide. I decided to go with the y's because the signs were already different and I could just multiply by 2 plus numbers. So let's go ahead and do that. I'm going to multiply equation 1 by 2, and I'm going to multiply equation 2 by 3. So taking equation 1, first of all, I have 2x times 2 is 4x, minus 3y times 2 is minus 6y, equals 9 times 2 is 18. And then multiplying equation 2 by 3, I get 5x by 3 is 15x, plus 2y times 3 is plus 6y, and finally 13 times 3 is 39. I draw a line underneath and I'm going to sum the two lines. 4x plus 15x is 19x, and then minus 6y plus 6y, they eliminate or give 0, and so the y's are eliminated from the question. Equals 18 and 39 is 57. I'm going to divide both sides by 19 and I get x equals 57 divided by 19, which is 3. So I'm going to sub x equals 3 back into equation 2. I'm going to select this time just because there's all pluses in that equation. So I'll write down the equation first of all. So 5x plus 2y equals 13. I have 5 times x is equal to 3 plus 2y equals 13. 5 times 3 is 15 plus 2y equals 13. I'm going to subtract the 15 from both sides to get 2y equals 13 minus 15. 2y equals 13 minus 15 is minus 2. And finally, I'm going to divide both sides by 2 to get y is equal to minus 1. So in this simultaneous equation, we have values of x equal to 3 and y equal to minus 1. So had we multiplied the top line by 5 and the bottom line by minus 2 to cancel the x's, I would have got the same two answers, but I would have got the y answer first, and I would have subbed this back into either equation to then get the x value. So there's no order that you have to do these questions in, but a rough rule of thumb that I use is that if the signs are different at the start in one of the variables, that's generally the one that I'll try and cancel first. So example 6 is the first example of two equations that are in the incorrect order. So both equations are not at the minute in the order ax plus by equals c. And so we're going to initially spend some time manipulating each equation so that they're in that correct format. So equation 1, first of all, we have 2x minus 3y minus 2 equals 0. And we can see that the minus 2, the number term, is on the wrong side of the equal. So all we're going to do is we're going to add a 2 to both sides of this equation. So the equation becomes 2x minus 3y. If we plus 2 to the left hand side, it will get rid of that minus 2, and then we'll have a plus 2 on the right hand side. And so now equation 1 is in the correct order. So similarly with equation 2, let's write it down. First of all, we have 3x equals 41 minus 5y. And so this time the minus 5y is on the wrong side of the equal sign. So we have 3x. I'm going to add 5y to both sides, which will get rid of the minus 5y from the right hand side and place a 5y on the left hand side. And that's equal to 41. And so now both equations are in the correct format. What I have to have a look at now is whether I can multiply one of the lines to get either the x's or the y's to eliminate. And from a quick glance at both lines, I can see that I can't. 2 is not a factor of 3, and 3 is not a factor of 5. So it's not going to be enough to multiply one of the lines. Again, I'm going to select the y's to eliminate, And I have a minus 3y in equation 1, and I have a plus 5y in equation 2. The lowest number that both 3 and 5 go into is 15, and so I'm going to try and change equation 1 into minus 15y and equation 2 into plus 15y. And the way that I'm going to do that is I'm going to multiply equation 1 by 5, and I'm going to multiply equation 2 by 3. And if I multiply equation 1 by 5, I'll get the y to be minus 15y, and if I multiply equation 2 by 3, I'll get the y's to be plus 15y. So let's go ahead and do that. So equation 1, I'm multiplying every term in equation 1 by 5. I get 2x times 5 is 10x, minus 3y times 5 is minus 15y, and equal to 2 times 5 is 10. Equation 2, multiplying every term in the equation by 3, I get 3x by 3 is 9x, plus 5y times 3 is plus 15y, and then 41 times 3 is 123. I'll draw a line underneath, and I'm going to add both lines together. 10x plus 9x is 19x. Now, minus 15y plus 15y is 0, so that eliminates the y's, which is what we were trying to do. And then equals 10 plus 123 is 133. If I divide both sides by 19, I get x is equal to 133 divided by 19, which is 7. So thus far what we've said is to sub this value of x into one of the original equations, but it is okay to sub it into one of the manipulated equations. So I can see that equation 2 here has all plus signs, and so I'm figuring this is probably going to be the easiest equation to sub it back into, and it's fine to sub it either into the original equations or one of the manipulated equations. So equation 2 had become 3x plus 5y equals 41, and that's the equation that I'm going to use. So I have 3 by x, which is 3 by 7, plus 5y equals 41. 3 times 7 is 21, plus 5y equals 41. Subtracting 21 from both sides, I get that 5y is equal to 41 minus 21. I get that 5y equals 41 minus 21 is 20. I'm going to divide both sides by 5, and I get y is equal to 20 divided by 5, which is 4. And so the final solution to this simultaneous equation is that x is equal to 7 and y is equal to 4. And so this is our first example where we not only had to multiply both lines by numbers to get one of the letters to cancel or to eliminate, but we also had to rearrange the equations at the start of the sum as they were in the incorrect order. And we need them to be in the order ax plus by equals c before we start the sum and decide upon multiplying lines. So example 7 is the first example of a question where one of the equations has a fraction in it. So let's have a look at how we might handle this. So writing down the two equations once again. So equation 1 is 2x minus y equals 22, and we can see that this is in the correct format. Equation 2 then, we have that x plus 4y is equal to x minus 4 all over 3. And so we have this fraction on the right hand side, and we also have an x term on the right hand side which we'll have to get rid of as well. So the first thing I'm going to do is, with equation 2, I'm going to multiply both sides by 3. I can see that if I multiply both sides by 3, that will get rid of the fraction from the right hand side. So multiplying the left hand side by 3, I have 3 on x plus 4y, and that's equal to 3 on x minus 4 over 3. Now some people, when they're writing down this and multiplying both sides by 3, they may not write this 3, they may just cancel this 3 on the bottom, which we'll do in a minute, but I'm just writing down the step to see that we did the same thing to both sides, which we're allowed to do. I'm going to multiply out the left hand side, so 3 by x is 3x, and 3 by 4y is 12y, and then as we've said, 3 divided by 3 is 1, and so they kind of cancel. On the right hand side then, I'm left with x minus 4. So the fractions are gone, but I'm left with this x on the right hand side, and I'm trying to get in the format ax plus by equals c, and so I need to remove that x from the right hand side. And the way that we're going to remove that x is we're going to subtract an x from both sides. So on the left hand side, I have 3x plus 12y minus x, so I'm subtracting an x from the left hand side, and then I'm subtracting an x from the right hand side, which is going to get rid of that x that's there, and I'm just left with minus 4. So 3x minus 1x is 2x, then I have the 12y, and that's equal to minus 4. So when you're tidying that up, some people might have shorter versions of doing it, some people might have longer versions of doing it. But once we kind of obey the rules of maths and we do the same thing to each side, we can manipulate the equation to get it in the right form, which is that the x's come first, and then we have the y's, and then we have the equals, and then the number. I can see in this equation that I have a 2x in equation 1, and I also have a 2x in equation 2, the manipulated version of equation 2. So all I'm going to have to do is I'm going to have to multiply equation 2 now by -1, and that will eliminate the x's. So let's go ahead and write down equation 1 as it is from the start of the sum, which is 2x minus y equals 22. We haven't manipulated that one at all. And then let's write down equation 2 multiplied by -1. And so equation 2 becomes 2x by -1 is -2x, plus 12y times -1 is -12y, and -4 times -1 is equal to +4. I'm going to draw a line underneath, and I'm going to add the two lines. So 2x minus 2x is 0. They cancel out or eliminate. Then I have -y minus 12y, which is minus 13y, and then I have 22 plus 4 is 26. If minus 13y is equal to 26, and I divide both sides by minus 13, I have that y is equal to 26 divided by minus 13 is -2. And so that's the first solution to the simultaneous equation. I can sub this into either of the original equations or into the manipulated version of equation 2. So I'm going to sub it into the original equation 1 and see can we solve then for x. So equation 1 was 2x minus y equals 22. I'm going to sub in -2 for y, so I have 2x minus -2 equals 22. I have 2x minus by a minus is a plus 2 equals 22. I'm going to subtract the 2 from both sides to give me 2x equals 22 minus 2. So 2x equals 22 minus 2 is 20. And then divide both sides by 2 and I get x is equal to 10. And this gives me a final solution to the simultaneous equation of x equals 10 and y equals -2. Now, this was the first time we met fractions, so what we had to do with equation 2 was we had to first get rid of the fraction, and then we had to manipulate the resultant equation so that it was in the correct form, ax plus by equals c. And once the two equations are in that form, we can then decide about multiplying one or both lines by a number to try and eliminate one of the variables in the question. So example 8 is another example where we have fractions in one of the equations, and this one just slightly trickier probably than the last. So equation 1, if we write it down, first of all, it doesn't need to be manipulated. We have 3x plus y equals 22, and it's in the correct format. Equation 2 has the fractions, and so if we write it down, first of all, we have x minus 3 all over 2 minus 2y plus 4 all over 3, and that's equal to 0. I'm going to multiply across by the lowest common denominator in this question, which is 2 and 3 both go into 6. And if I multiply across by 6, it will get rid of all the fractions in the question. So the left-hand side becomes 6 on x minus 3 over 2 minus 6 on 2y plus 4 over 3. And technically we're multiplying the right-hand side by 6 as well, even though we have a 0 on the right hand side, and anything multiplied by 0 will still give 0. So 2 into 6 goes 3 times, x minus 3, minus 3 into 6 goes 2 on 2y plus 4, and that's equal to 6 times 0 is 0. Multiplying out the fractions, I get 3 times x is 3x, 3 times minus 3 is minus 9, minus 2 times 2y is minus 4y, and minus 2 times plus 4 is minus 8, and that's all equal to 0. We're trying to get the equation in the form ax plus by equals c. So I'm going to keep the x and the y terms on the left hand side. So we have 3x minus 4y on the left. And then to get rid of the minus 9 and minus 8 on the left hand side, I'm going to add a 9 and an 8 to both sides. And so my final equation is 3x minus 4y equals 9 and 8 is 17. So a lot of people, when multiplying across by 6, can skip a couple of lines of that manipulation. Depending on your skills with algebraic fractions, there is an upcoming video on simplifying algebraic fractions and solving algebraic equations with fractions. And so if your skills were a little rusty in that area, you can go and check out that video. We are now left with two equations in the right format, ax plus by equals c, and we have to decide what to multiply one or both of the equations by to eliminate one of the variables in the question. I can see that both equation 1 and equation 2, the manipulated version, have a 3x, and so if I multiplied either of those equations by -1, I'll be able to eliminate the 3x. But I could also eliminate the y's easily enough, so I can see that I have a -4y in equation 2, and if I multiplied equation 1 by 4, I could turn the y into a +4y and the y's would eliminate. So I'm going to go ahead and eliminate the x's because the numbers are already the same in that question. It seems like the most logical thing to do. So let's write down equation 1 first of all, which hasn't changed since the start of the sum. 3x plus y equals 22. And then we're going to multiply equation 2 by -1. And so it becomes 3x times -1 is -3x. We have -4y times -1, which is +4y. And we have 17 times -1, which is -17. We're going to draw a line underneath and we're going to add the two lines together. So 3x minus 3x give us 0, so the x's eliminate. We have +y plus 4y is +5y. And we have 22 minus 17, which is +5. 5y equals 5, so if we divide both sides by 5, we get that y is equal to 1. And so we've solved for our first variable in the question. So I'm going to take this value of y and sub it back into equation 1. Remember, I can sub it into either of the original equations or any of the manipulated ones. So we're going to sub it into one of the original equations, 3x plus y equals 22. So 3x plus y, remember, is equal to 1, so equals 22. We're going to subtract the 1 from both sides and we get 3x equals 22 minus 1. 3x equals 22 minus 1 is 21. And then we're going to divide both sides by 3 to give us x equals 7. And so the solution to this simultaneous equation is that x is equal to 7 and y equals 1. So example 8, like example 7, just involved us having to simplify a fraction that was in an equation first of all, and then to manipulate that equation so that it was in the correct format. Ax plus by equals c. And then remember, when both equations are in that format, we can decide what to multiply one or both of the lines by to calculate one of the variables. So examples 9 and 10 are examples of worded questions where we have to go and form the simultaneous equations before going and solving for x and y. There's a separate pack of worded simultaneous equations attached to this session, and if people want to go and practice those, and they're all taken from the past exam papers, and they involve this exercise of forming the equations before solving for the missing variables. So let's go ahead and read the question and we'll form the equations and go and solve for x and y. So we're told that the cost of 2 jumpers and 3 shirts is 84 euros and the cost of 4 jumpers and 1 shirt is 78 euros. They tell us to use x as the variable for the cost of a jumper and y as the variable for the cost of a shirt. And what we have to do is write down 2 equations, first of all in x and y. So I can see that equation 1 is quite simple. I know that the cost of 2 jumpers, so how would you find the cost of 2 jumpers? Well, if the cost of a jumper is x and you're going to buy 2 of those jumpers, well then if you multiply 2 by x, that will be the cost of the 2 jumpers. Then we're going to buy 3 shirts, and I know that the cost of 1 shirt is y. I'm going to buy 3 of them, so if I multiply 3 by y, that will give me the cost of the 3 shirts. And I know that the total cost of the 2 jumpers and 3 shirts is 84 euros, or equals 84 euros. Similarly with equation 2, we're told now that 4 of the jumpers, and how would you find the cost of 4 of the jumpers? Well, you'd multiply 4, the number of jumpers you're buying, by x, the cost of a jumper, plus 1 shirt. So 1 shirt is just a value of y, and we know that the sum of those is equal to 78 euros. So 4 jumpers and 1 shirt equals 78 euros. So in this example, quite easy to form the 2 simultaneous equations. So once we have the equations formed, we check that they're in the right format. So ax plus by equals c, which they are, and then we decide to multiply one or both of the lines to eliminate one of the variables. So most people can probably see quickly enough in this question that we could either multiply the top line or the bottom line to get either the x's or the y's to eliminate. I'm going to decide to eliminate the y's, which means multiplying the bottom line by minus 3. So writing out both my equations again, equation 1, 2x plus 3y equals 84. And then multiplying all the terms in equation 2 by minus 3, I get that 4x times minus 3 is minus 12x, y times minus 3 is minus 3y, and 78 times minus 3 is minus 234. I'm going to draw a line underneath and add both lines. So 2x minus 12x is minus 10x. So 3y minus 3y give me 0, and so the y's are eliminated. And then I have equals 84 minus 234 is minus 150. If minus 10x equals minus 150, I can divide both sides by minus 10, and I get x is equal to minus 150 divided by minus 10, which is plus 15. Remember, a minus divided by a minus is a plus. Again, I can sub this value of x equals 15 into either equation 1 or equation 2. So I'm going to decide to sub it into equation 2. So I write down equation 2 again, and I get that 4x plus y equals 78. I know that x is equal to 15, so I now have 4 times 15 plus y equals 78. 4 times 15 is 60 plus y equals 78. I'm going to subtract a 60 from both sides, and I get y is equal to 78 minus 60. And then finally, y is equal to 78 minus 60 is 18. And so I have x is equal to 15 and y is equal to 18. So in this question, remember, we're talking about a monetary value. So x is the cost of a jumper. So a jumper, x is equal to 15 euros. And a shirt, y is the cost of a shirt, y is equal to 18 euros. Okay, so let's have a look at example 10, which I think the wording is slightly trickier than the last example. I think some people find the two equations a little more difficult to solve, and we'll just talk about that as we read through the question and then go and try and form them. So we're told that Helen buys stamps costing 48 cents and 60 cents. So there's two types of stamp, and later in the question we're told that x is the number of 48-cent stamps and y is going to be the number of 60-cent stamps. So they're the only two stamps she buys. She buys X 48-cent ones, and she buys Y 60-cent stamps. In reading the next line of the question, we're told that she buys a total of 50 stamps. And this is the equation that a lot of people find difficult to form. They don't realize that if you added the number of 48-cent stamps to the number of 60-cent stamps, it should add up to 50, the total amount of stamps that she bought. So a lot of people actually do struggle to spot that sentence in the question. The second sentence is about the value of all the stamps. We're told that the total cost of all the stamps was 25 euros and 68 cents. The first thing I would do in this question is we can't mix cent and euros. We're told that the stamps are 48 cent and 60 cent, and yet we're given a total value in euros. So I'm going to change that 25 euros and 68 cent to 2,568 cents so that we can use a common unit of measurement in the question. So the value of the 48-cent stamps added to the value of the 60-cent stamps adds up to 2,568. So what's the value of the 48-cent stamps? Well, there's x of them first of all, and if we multiply the number of them by the value of each one, 48 cent, that'll be the total value of the 48-cent stamps. What's the value of the 60-cent stamps? Well, there's y of them first of all, and each one has a value of 60 cent. So if you multiply y, the number of them, by 60, the value, that'll be the value of all of the 60-cent stamps. And we know that if we add all of this together, the total cost of all the stamps was 2,568. Just tidying up that equation, I get 48x plus 60y equals 2,568. We now have two sentences that are in the correct format, ax plus by equals c, and we can decide what to multiply one or both of the lines by to try and eliminate one of the variables. Because we have a solitary x and y in equation 1, I can either multiply equation 1 by minus 48 to eliminate the x's, or minus 60 to eliminate the y. So I think I'll just decide on multiplying by the smaller of the two numbers, the 48. So equation 1, I'm going to multiply by minus 48. And equation 2, I'm going to multiply by, and I'm going to leave equation 2 exactly as it is. So multiplying each term in equation 1 by minus 48, I get x by minus 48 is minus 48x. Y by minus 48 is minus 48y. And 50 by minus 48 is minus 2,400. Equation 2 is exactly the same, so we have plus 48x plus 60y equals 2568. So I'm going to draw a line underneath, and I'm going to add both lines. When I add the x's, I get minus 48x plus 48x gives me 0x, so they eliminate. Adding the y's, I get minus 48y plus 60y is 12y. And then the numbers minus 2,400 plus 2568 gives me 168. So 12y is equal to 168. If I divide both sides by 12, I get that y is equal to 168 divided by 12, which is 14. So I know that there was 14 60-cent stamps. I'm going to sub this into equation 1. Remember, I can sub it into either of the original equations or the modified one. So I'm going to sub it into the original equation 1, which was just x plus y equals 50. And some people will see, well, look, if x is 14, what do I have to add 14 to get 50? That'll just be 36. But it is a good idea anyway to do the substitution. So we have x plus 14 equals 50. I'm going to subtract a 14 from both sides, and I get x equals 50 minus 14, which is 36. And so just putting the answers together, the final solution to the simultaneous equation is that x equals 36, meaning there was 36 48-cent stamps, and y is equal to 14, meaning there was 14 60-cent stamps. So that's the 10 basic examples. Hopefully people saw a bit of variety in those. Some of the questions involved manipulating the original equations so that they're in the correct format. Others involved multiplying one or both of the lines so that the variables would eliminate. Other questions then had fractions in them, and how do we deal with getting rid of those before we can start the sum. And then the final couple of examples looked at worded problems where we have to form the equations before we can actually go and solve them. And solving them was actually quite easy. The equations were basic, far easier maybe than some of the ones where we had to manipulate fractions. But it's in forming the equations that people can find difficulty, particularly as we move into Leaving Cert higher level and the worded problems are of a slightly higher order. If people want to go and practice either your basics in simultaneous equations, there's a pack just for the algebra of those, and then there's a separate pack for those people who want to practice some of the worded questions. If you want to see some trickier questions, stay with the video. We're going to look at 10 trickier examples, or at least examples that have been modified from Leaving Cert higher level papers or trickier Junior Cert higher level or Leaving Cert ordinary level questions. So I'd recommend students go and try the 10 trickier questions first themselves before they go and watch the video. That way you can test what you remember from your Junior Cert, and it may only be a small little thing that you're getting incorrect, and that way you go and watch the video, make the little correction on whatever it is you're making a mistake with, and I think by doing it that way you reinforce what you already know, and then you'll remember in a better way the things that you're kind of having difficulty with, or the places that you're making mistakes. So let's spin over to those. So we're going to take a look at some Leaving Cert higher level questions where simultaneous equations have been needed to solve the problems. So in the first question, which has been modified from a paper 2 question on the coordinate geometry of the line, we're given two equations, and in this question these two equations were the equations of lines. And by doing a simultaneous equation on two lines, we can find the point of intersection of those two lines. So let's write down the two equations. The first equation is already in the correct format, ax plus by equals c. So we have the x term first, 4x, then we have the y term plus 3y, and then we have an equals, and the number on the other side equals 45. Equation 2 has to be manipulated slightly. So at the minute we have an equation that reads 3x minus 4y plus 10 equals 0. And quite often when we're given the equation of a line, all the terms will be on the left hand side, and so there's some manipulation involved if we're going to do a simultaneous equation and find the point of intersection. Equation 2, what I'm going to do to get the x term and the y term on its own on the left hand side and get rid of the 10 is I'm going to subtract a 10 from both sides, which means that the 10 gets removed from the left hand side and we get a 10 on the right hand side, or a minus 10. From looking at equation 1 and the manipulated version of equation 2, I can see that I'm not going to be able to multiply just one of the lines to be able to cancel either the x's or the y's. So what I'm going to do is I'm going to select one of the variables, so I'm going to select the y's, and I'm going to try and eliminate the y from each equation. And the way that I'm going to do that is I'm going to select the lowest common multiple of 3 and 4. Now you might ask, why am I not selecting the x's? Because the y's already have different signs, it means that I can multiply both of the lines by a plus number, and it'll just make the multiplication slightly easier if I select the variable that already has different signs. The lowest common multiple of 3 and 4 is 12, so I'm going to try and turn equation 1 into 12y and equation 2 into minus 12y. And the way that I'm going to do that is, well, 3y goes into 12y 4 times, so I'm going to multiply equation 1 by 4, and minus 4y goes into minus 12y 3 times, so I'm going to multiply equation 2 by 3. And that should allow me to eliminate the y's. So writing down the two equations again, so equation 1, which I'm going to multiply by 4, and then equation 2, which I'm going to multiply by 3, I get with equation 1, 4x times 4 is 16x, plus 3y times 4 is plus 12y, and 45 times 4 is 180. Equation 2 I'm multiplying by 3, so I have 3x times 3 is 9x. I have minus 4y times 3 is minus 12y. And then I have minus 10 times 3, which is minus 30. I draw a line underneath and I'm going to add both lines. 16x plus 9x is 25x. And plus 12y minus 12y gives me 0, and so the y's are eliminated from the equations. Finally, I have 180 minus 30, which is 150. 25x equals 150, so if I divide both sides by 25, I get that x equals 150 divided by 25, which is 6. And so the value of x in this question is 6. I'm going to sub x equals 6 back into either of the equations, so I'm going to select equation 1 just because it has all positive signs and I think the calculations will be slightly easier. So equation 1 is 4x plus 3y equals 45. So we have 4 times x equals 6 plus 3y equals 45. 4 times 6 is 24 plus 3y equals 45. If I subtract the 24 from both sides, I get 3y equals 45 minus 24. So 3y equals 21. And then if I divide both sides by 3, I get that y is equal to 21 divided by 3, which is 7. And so the solution to this simultaneous equation is that x is equal to 6 and y equals 7. Now, if this was a coordinate geometry of the line question, we can put the 6 and the 7 in a bracket. And we know that that's the point of intersection of the two lines, the point 6, 7. So example 2 has also been modified from a coordinate geometry question, this time the coordinate geometry of the circle. And quite often when we have equations that have g's and f's in them, we're looking to find the center of a circle. So we have equation 1, which is minus 3g minus 4f minus 46 equals 0. And the first thing we'll notice is that this obviously isn't in the correct format. So what I'm going to do is I'm going to add a 46 to both sides to leave me with minus 3g minus 4f plus 46 on the left. We'll get rid of the minus 46 and then we have a plus 46 on the right. And so that now is in the correct format. Equation 2 is already in the correct format, so we'll just write that one down. So we have minus g plus 7f equals minus 43. So looking at equation 1 and equation 2, I can see that it's going to be easier to try and eliminate the g's, and I can do that by multiplying equation 2 by minus 3. So writing the two equations again, equation 1 is going to remain unchanged, so we have minus 3g minus 4f equals 46, and then equation 2 I'm going to multiply by minus 3. Minus g times minus 3 is plus 3g. 7f times minus 3 is minus 21. f, and that's equal to minus 43 times minus 3 is equal to plus 129. So I draw a line underneath and I add the two lines. Minus 3g plus 3g is equal to 0, so the 3g's are eliminated. Minus 4f minus 21f is minus 25f, and 46 plus 129 is 175. If I divide both sides by minus 25, I get that f is equal to 175 divided by minus 25 is minus 7, and so f is equal to minus 7. So I can sub f equals minus 7 back into either original equation. So I'm going to choose equation 2, and equation 2 reads that minus g plus 7f equals minus 43. So minus g plus 7 times minus 7 equals minus 43. Minus g minus 49 equals minus 43. I'm going to add a 49 to both sides to give me that minus g equals minus 43 plus 49. And I get minus g equals plus 6. And then if I divide both sides by minus 1, I get that g is equal to minus 6. And so the solution to this simultaneous equation is that g equals minus 6 and f equals minus 7. So example 3 has also been taken from a coordinate geometry question. We have two equations as we did in the previous examples with variables x and y. And so we're looking in this question to find the value of x and the value of y. But we're asked to give our answer in terms of m. So there's an extra letter in the question m. M in coordinate geometry stands for the slope. And in this question, we haven't been given a numerical value for m. We're just told that the slope is m. And so we have to proceed with the question not knowing that value and giving our answer then in terms of m. So let's see how we might do this question. So the first thing we're going to do is we're going to write down the two equations. So equation 1 is in the correct format. We have an equation that reads 4x plus 3y equals 25, and we just have x's and y's in that equation. The second equation then, equation 2, it reads 3mx minus 3y equals 18m. And this is in the correct format as well. We have our x variable, we have our y variable, we have equals, and then we have the number on the other side. So I can see in this question that I'm actually not going to have to multiply either line in this example. If I draw a line underneath, I can add the lines straight away and eliminate the y variable from the question. So I have 4x plus 3mx, which gives me 4x plus 3mx. I have 3y minus 3y, and 3y minus 3y is 0, so they cancel. And then I have equals 25 plus 18m. Now I'm trying to get the x variable on its own, so on the left hand side I'm going to factorize the x, and I have x on 4 plus 3m equals 25 plus 18m. So to get the x on its own, I'm going to divide both sides by 4 plus 3m. So on the left hand side, 4 plus 3m divided by 4 plus 3m is just 1, so I just have x. And then on the right hand side I have 25 plus 18m over 4 plus 3m. And that's the value of my x variable in terms of m. And we can't break it down further than that. What we did in the previous examples, we subbed the x value back into equation 1 or 2. So I'm going to sub it back into equation 1. So let's write down equation 1. And we're going to replace the x value with the value that we've just found, 25 plus 18m over 4 plus 3m. So I'll write down the equation first of all, 4x plus 3y equals 25. And then on the next line, I'm going to replace the x with 25 plus 18m over 4 plus 3m. Plus the 3y equals 25. And remember, we're trying to get y on its own here to find the value of the y variable in terms of m. I'm going to multiply out the top of the fraction. So I have 100 plus 72m over 4 plus 3m plus 3y equals 25. I'm going to remove all of the terms on the left that aren't y's, and the way I'm going to do that is I'm going to subtract 100 plus 72m over 4 plus 3m from both sides. So on the left I'm left with 3y, and then on the right hand side I have 25 minus 100 plus 72m over 4 plus 3m. So before I divide across by the 3 to get the y on its own, I'm going to tidy up the right hand side by simplifying the fraction. So I'm going to get a common denominator, which is 4 plus 3m. Remember that 25 is the fraction 25 over 1. Now 1 into 4 plus 3m goes 4 plus 3m times 25, minus 4 plus 3m into 4 plus 3m goes once on 100 plus 72m. So I get that 3y is equal to, I'm going to multiply out, 4 by 25 is 100, plus 3m by 25 is 75m, minus 1 by 100 is minus 100, and minus 1 by 72m is minus 72m. And that's all over 4 plus 3m. So I have 3y equals, now 100 minus 100 is 0, and 75m minus 72m is 3m all over 4 plus 3m. And then the final line is I'm going to divide both sides by 3, and we'll just come over here for this work, and I get y is equal to m over 4 plus 3m. And so the answer to this simultaneous equation is that x is equal to 25 plus 18m over 4 plus 3m, and that y is equal to m over 4 plus 3m. So just an example where we give our answer in terms of some other letter that we haven't been given the value of in the question. So example 4 is a question that's been heavily modified from an algebra question on a Leaving Cert higher level paper. So it was quite a long question. This was the final part. It was only rewarded 5 marks, and there's quite a bit of work in this, in particular in actually making these two equations. So we're going to solve this simultaneous equation, but there would have been quite a bit of work in actually getting to this stage in the first place. The first thing to note is that technically this isn't a linear equation. There's two variables, n and y, but if we were to multiply out the bracket, we'd have this ny term, and so technically these aren't linear equations. The method is so similar though that I just wanted to show the example here, and we'll see how it kind of reduces to a simultaneous equation that similar to the ones we've done previously. So as I write down the two equations, what I'm going to do is I'm actually going to multiply out the brackets. So I have 16n, so 25,000 over 4 times y, which gives me plus 25,000 y over 4. And then I have minus n over 4 times y, which gives me minus n y over 4. And this is all equal to 365,000. Equation 2 I'm going to multiply out as well. So in equation 2 I have 16 times n, which gives me 16n. I have 16 times minus 4,000, which gives me minus 64,000. I have 29,000 over 4 times y, which gives me plus 29,000 over 4 y. And then I have minus n over 4 times y, which gives me minus n y over 4. And this is all equal to 351,000. So I have number terms on both sides of equation 2. So I'm just going to simplify those number terms first of all. So I have 16n. I'm going to add a 64,000 to both sides. So on the left I'm left with plus 29,000 y over 4 minus ny over 4 equals, and then I have 351,000 plus the 64,000, which gives me 415,000. So I can see here that if I was to multiply equation 2 by minus 1, not only would I cancel the 16n's, I'd also cancel or eliminate the ny over 4's. So let's have a look at that by writing out each equation again. So equation 1 we'll write out here on the right hand side, and I have 16n plus 25,000 over 4 y minus ny over 4 equals 365,000. And then equation 2 I'm going to multiply by minus 1, and I get minus 16n. Then I have minus 29,000 y over 4. I have plus ny over 4, and then that's equal to minus 415,000. I'm going to draw a line underneath, and I'm going to add the two lines. So 16n minus 16n is 0, and so they're eliminated. minus ny over 4 plus ny over 4, they're eliminated. So even though I had a nonlinear term in the equation, it got eliminated after I multiplied one of the lines by minus 1. So adding down the rest of the terms, I have 25,000y over 4 minus 29,000y over 4, which is minus 4,000y over 4. And then the numbers on the right hand side, I have 365,000 minus 415,000, which gives me minus 50,000. Minus 4,000 over 4 is minus 1,000, so minus 1,000 y equals minus 50,000, and then dividing both sides by minus 1,000, I get y equals 50. And so we've solved for y. So we're going to take our solved for value of y equals 50, and we're going to sub this into equation 1. Now we could sub it into equation 1 or equation 2, but equation 1 looks like it's going to be less work. So equation 1 now becomes 16n plus 25,000 over 4 times 50 minus n times 50 over 4, and that's equal to 365,000. So we get 16n plus 25,000 times 50 divided by 4 is 312,500 minus n times 50 over 4 is equal to 12.5n, and that's equal to 365,000. I'll collect the n terms on the left, so I have 16n minus 12.5n, and then to get rid of the 312,500 from the left, I'm going to subtract a 312,500 from both sides. And so on the left hand side I have 3.5n, and on the right hand side I have 52,500. Dividing both sides by 3.5, I have n is equal to 15,000. And so the solution to this simultaneous equation is that y is equal to 50 and n is equal to 15,000. So to me that's an extremely difficult question. It was tricky, first of all, to come up with these two equations from the written problem on the papers, but then even the calculations involved in solving the simultaneous equation once you had the algebra, that was hard as well. And all of that work then unfortunately was only rewarded for the people who got it right with 5 marks. So the final Leaving Cert higher level example has actually been taken from a Leaving Cert applied maths paper. So it's not a topic that a lot of students would do. A small percentage of Leaving Cert students would take the applied maths paper, but it is useful to see the application of simultaneous equations in a practical question like this. So we're looking to solve for two variables, t and a. It's not important to us in terms of solving the equations, but t stands for the tension in a rope and a stands for acceleration. So equation 1, we're told that 3.92 minus t equals 0.4a, and we can see that the variables here are in the wrong place, but having formed this equation, this would have been the way we would have formed the equation, and we're going to have to rearrange it or manipulate it so that the variables are on the left hand side and the numbers are on the right hand side. So what I'm going to do is I'm going to have the t variable come first, so I have minus t, and then I want the 0.4a on the left hand side, so that means subtracting a 0.4a from both sides. And then I want the numbers on the right hand side, which means subtracting 3.92 from both sides. So equation 2, if we write it down first of all in the way that it's been presented, so t minus 2.94 equals 0.3a, we can see again the variable is on the wrong side of the equals. And so what we're going to do is we're going to keep the t at the front, then we're going to subtract 0.3a from both sides, and add a 2.94 to both sides. And so I have the variables on the left and I have the numbers on the right. I can actually see with this example that the minus t and the t will eliminate straight away if I add the two lines. So I just want to write them again over here on the right hand side, one directly above the other one so we can see that more clearly. So we have minus t minus 0.4a equals minus 3.92, and then equation 2, which I'm going to write directly underneath it, I have plus t minus 0.3a equals 2.94. I'm going to draw a line underneath and I'm going to add the lines. Minus t plus t is 0. And so the t's have been eliminated. 0.4a minus 0.3a is minus 0.7a. Minus 3.92 plus 2.94 is minus 0.98. If I divide both sides by minus 0.7, I get that A is equal to minus 0.98 divided by minus 0.7 is 1.4. And so the value of A in this question is 1.4. I'm going to sub this back into equation 2. So I'm going to write down equation 2 again. And I have t minus 0.3a equals 2.94. I know that a is 1.4, so I have t minus 0.3 times 1.4 equals 2.94. I'm going to multiply minus 0.3 times 1.4, and I get minus 0.42 equals 2.94. T is equal to, I'm going to add plus 0.42 to both sides, so I get 2.94 plus 0.42, and then finally I get my value for t, which is 2.94 plus 0.42, which is 3.36. And so the solution to this Leaving Cert applied maths question is that t was equal to 3.36 and a was equal to 1.4. So the last 5 examples are examples that have been taken from Leaving Cert Ordinary Level and Junior Cert Higher Level papers. They're of a similar difficulty level to the last of the basic examples. There's some fraction questions and there is some worded problems. The work solutions are attached to this lesson, so go and have a look at those, and if people have any questions they can get on to me to make a video to clarify any of those.